Hello folks, welcome back. In this class, we are talking about mutually exclusive events. In our previous class, we talked about how the set intersect or intersection of sets, and we discussed the union of sets. Let's now look at mutually exclusive events or sets, and I'll be having at least a freedom to use some probability theory terms. Alright, what do we mean by mutually exclusive sets? Remember, sometimes people do confuse between dependence, independence, and mutually exclusive event. So when we are having mutually exclusive event, we simply mean that A and B do not touch each other. Okay, do not touch each other, and we have to know their intersection. Let's say this is A and this is B. As we look forward to, remember, we are going from basic to now going to probability theories. Like, we are going to look at dependence and independence. We are going to look at conditional probability. We're going to look at the law of total probability. Then we look at additive rule, and then multiplicative rule, and then Bayes law. So it is important to really understand this small concept so that it won't be having a lot of effect when you do or deal with solving probability problems. Remember also, during our combinatorics classes, we said you have to read between lines with probabilities, because just a little twist in the problem changes the entire situation you're dealing with. So every time you are dealing with probability, I think it is only time I apply a lot of English or grammar concepts in mathematics, because you really have to understand, right, what the situation is. Okay, so let's say A union B. What did we say for a mutually exclusive set? Now we have a freedom to use the term when they do not touch each other. What is their union? The union is A plus B, right? And what is their intersection? A intersection B is equal to A, no, it is interesting to say A anyway. The intersection will be a null set because they are not touching each other. You can even think of this as a union. We said union of A and B is equal to A plus B minus A intersection B. So here, that is why we have union of A and B to be A and B only, because our intersection is a null set. Great. Let's go and look at the concept of dependence and independence. All right. Independent events are events whose theoretical probability remains unaffected by other events. People do usually confuse between independent event and mutually exclusive events. We said mutually exclusive event is the event that cannot occur simultaneously. If one occurs, the other one is the sure that it won't occur. And we have looked at the characteristics like the union and the intersection. Independent event is something different, a different concept, that if theoretical probability of an event is not affected by the other event, then we are saying two events are independent. For example, when flipping a coin, you always have 50% of chance of getting head regardless of the result you obtained in a previous flip. Let's deal with this mathematically. We know what a true probability is from our previous discussion when we are introducing to probabilities. We said these are the probabilities of some categorical outcome which we don't have to do experiment to know them. All right. The probabilities remains unaffected by the other event. For example, probability of having A, let's say, or let's start with let's A be an event of getting head when a coin is tossed, and B be an event of getting head on a previous toss. Interesting, right? On a previous toss. So what do you think? The probability of getting head is equal to, we have one favorable outcome out of a sample space of 2 possible outcomes, so it is a half. Probability of getting head given we had head. So this is now conditional probability, and I'm introducing to you conditional probability before even we get there. Oh, what a lecture. So this is conditional probability. Here we're saying P of A, okay, P of A given B. P of A given B. What we are saying is what is the probability of getting ahead if we have known that previously or on the previous flip we got ahead. Does it change? It doesn't change, so it is still 0.5. So in this case we are having probability of A is equal to probability of A when we have two events, A given B. Sorry for that. I have to do something with that anyway. Here we're saying probability of, we have two events, remember. We have probability of getting head and also getting head on previous event. What if we got head in our previous event? Does it affect our current probability? And we have realized that they do not affect each other. So in this case, where the probability of A is equal to probability of A given B, or given head on the previous toss, in this case we say this is independent event. Independent. All right, in our next class we are going to look at dependent event. I hope this class is helpful. Thank you and enjoy learning.